Alright guys, here we go, adding and subtracting radicals. So we're going to have to use some of what we just learned about with simplifying radicals and use that to do the adding and subtracting of radicals. So that's really important. And that is usually the part that people forget about the most. So when I simplify all radicals, that means I'm treating each individual first. The individual term first. So we have to look out for number one, like you. Look out for yourself first. Don't worry about the whole group. Okay. So like looking at number one, I'm not worried about can I combine these or not. Well, the first thing is no, because these radicals are not the same. You can think of this kind of like variables. If this was 3x and 2y, you would not be able to combine them. Okay. So the radicals are like different variables if they have different numbers. If they were the same number, like if both of these were 12, then we could combine these, but we can't. So the first thing we always have to do is treat these individuals separate. So this one, if you think about this number 27, it's like, okay, are there any factors of 27 that can make this whole thing simplify? And the answer is yes, you can. So 27 can break down to what? Now you can do the calculator method, but this is small enough where I can do this faster if I do the factor tree. So 27 is 3 times 9, 9 is 3 times 3, so now 27 is 3 times 3 times 3, giving me a pair of 3's, and I do a pair because it's squared. So this will be 3 times, so this is this 3 carried out. And then here, for the radical, I have a single number 3 here, which goes on the outside, and then, oh no, backwards. One of my pairs goes on the outside, and then the single one goes on the inside. Whoops. So giving you this part will simplify to 9 radical 3. Okay, now this part simplifies. Okay, so wherever your pluses and minuses are, that's where you separate your terms and you see if you can simplify each individual term first before you do step 2 and step 3. So this one, 12. 12 breaks down to 3 and 4, and then 4 is, of course, 2 times 2. So yes, I do have a pair that can come out. So this gives me 2 times any of my pairs, and my pairs are the 2 radical 3, so the 3 goes inside because it's a single, giving me 4 radical 3. Alright, what operation did I have? I had a subtraction. So now I can see if both are simplified. Now I can see if I can combine them. And yes, radical 3 and a radical 3. So that's all you're looking for. Identify radicals with the same index, so the same root, and the same radicand, so the number underneath. So the root has to be the same. So if this was third root and this was third root, I could also combine them. But if this is third root and this is second root, then I cannot combine them. And then after that, you just add and subtract the coefficients, kind of like the variables I was saying, 9. So like up here, these are different, but now that I have the same thing, 9x minus 4x, and of course instead of x, I'm just saying that that's radical 3. Yes, I would combine those, and I would get 5x. So it works the same way here. I would just say 5 radical 3. And that's the answer for this one. Okay? Alright, let's also do number 3. Alright, treat each one as an individual. So I'm just going to draw like a dividing line for 48. Let's go ahead and refresh our calculator skills on this. We'll just go ahead and do these ones in the calculator. So you take your radical and divide it by x raised to whatever power you need. X raised to this was the 4th power. So 48 was my number, and then I had the 4th root. So I divide by x to the 4th. I get my table. 2, 3. Oh, that looks good. I can probably just use 2 and 3, which, yes, that was just checking to make sure that was right. So I didn't have to do any more numbers. As you can see, the more numbers I put, I'm getting below 1. That's also something you don't want to see. You don't want to see, you know, your answer is not going to be wherever the numbers are getting less than 1, close to 0. So 2, 3. The 148, again, you don't pick the one that's with the 1 x value. Okay, so we're going to take 2 and 3. So times 2's on the outside, and then 4th root of 3. So 4th root of 48 is equivalent to 2 4th root of 3. And to simplify the front. And I'm good. Now I do this one. Definitely, no, I cannot simplify that anymore. If this number is prime, you definitely can't simplify that. So that can just carry down. And so far, so good. Looks like we'll be able to subtract these. Okay, let's do the 72 now. Now, the roots are different. That is a big clue right away that this is going to stand alone. These two could possibly be combined because they're both 4th root, but this is 3rd root. So let's do the 72 in the calculator. And we get 2 and 9. 2, 3rd root of 9. 3 times 2 is 6, 3rd root of 9. And that was a plus. So this is the only thing I can simplify here at the end. 14 minus 2 is 12. 4th root of 3 plus 6, 3rd root of 9. And yeah, that's the answer. Okay. Alright, let's do a hard one. Let's do number 6. Alright, divide these up. Okay, now this one actually right here, I cannot split this up because this is technically a coefficient in front of this radical. So, and it's multiplication. You can only treat them as different terms when they're separated by pluses or minuses. So, let's start with the 3. 3rd root of 40. 40 is 5. Let's do this real quick. I think I can do it. 5 times 8, and 8 is always, oh, yeah, 2 times 2 times 2. Now, I'm doing groups of 3 that come out. So, and I know the negative comes out. Let's go ahead and pull the negative out. And then I have a group of 3. So a 2 will come out, but the 5 will stay. So 3rd root of, and then 5. Remember this number, if it breaks down, you no longer use it for your ending, just in case you may have forgot that. So I just had a single 5. Now I can look at my variables. Remember before we did the variables separate as well? Yeah, feel free to do that, you know. If you want to say, oh, I'm going to worry about the number first and then worry about the variable, yeah. But this is short enough to where I'm going to just do it in one whack. So how many groups of 3 come out of 7? That would be 2. So I know I'm going to have to come out with the a squared, and I'm kind of out of room, so I'm just going to put that out front. So how many a's am I left with? That would be, 2 times 3 is 6, so I took out 6 of them, and I'm left with 1. And I don't have to keep that 1. Let me simplify, make this look a little bit nicer. Negative 2a squared times the 3rd root of 5a. So I just worried about all of that. It's helpful when you just focus on one part at a time. Alright, out here, 135. Oh, let's go ahead and do this one in the calculator. 135 and 3, and it's already x to the 3rd. So we're good with that. There we go, 3 and 5. So that's going to simplify to 3 and 5. So 2a squared times 3, 3rd root, radical 5. Okay, now I need to do the a. And I can take out one set of a's. And then I would have one left over. Looks like we are going to get like terms. Alright, but I do have to combine the front. The front is going to be all multiplication. So 2 times 3 is 6. A squared times another a is a to the third, because that's really a times another a. That's really 3 a's. So remember, with multiplication, you add their exponents. So this is an exponent of 1, and when you multiply, then it becomes a 3, and then the third root of 5a. Okay, now that we have the correct, now that both sets are simplified, we can potentially add these. Now, the problem is going to be this. We don't have the same variable here. So actually, we're not going to be able to combine these. So that can be kind of challenging and tricky, because yes, they do have the same root and they have the same radicand, but when you have variables thrown in there, you can't just fix that, especially if this is a squared. Actually, I believe you could, if this was a squared and this was a squared, you could, but you can't, since these variables are different as well. But if they were the same, you could combine them. So all variables must match all the way through. So this is your answer, which is pretty long. Negative 2a squared, third root of 5a, plus 6a to the third times the third root of 5a. So let's put a note here. Cannot combine since coefficients have different variables. And that's this. The a cubed and the a squared are different. So that throws it off. Okay. Unfortunately. Alright, why don't you go ahead and try these other three on your own. And so pause the video and press play when you are ready to see. Alright, here are your answers. Number 2 is negative 7 times the third root of 2. Number 4 is negative 2 times the third root of 7. Number 5 is 4x squared times y times radical 2. Alright, now let's go over multiplying. So adding and subtracting, that you still have to do all that simplifying. It's still on the tricky side. Multiplying is much easier. So we're going to use the product rule. So with the product rule, as long as they have the same index, we can combine their radicands. So if I have n root of a times the same n root of a different number, that will combine and become n root of ab. I can just simply put a, b together under the same root. So it's kind of like terms. And then you will simplify the result. So for example here, they're both square roots. So I can combine them and put them under the same square root. 27 times 5 is 135. And then I just have to make sure 135 can't be simplified. It should always be a red flag if you have a big number like this under your square root, that you have to keep going, that you're not done. Never leave, a big number like that. You're like, oh, there's a good chance it could be reduced. So we had 135, but it was square root, so I got to change it to squared, which, yes, gives you a different answer. Alright, so we have 3 and 15. Is that what we're going to be? Yeah. Because 15 is 3 times 5, and I can't take out a pair out of 3 and 5. So, 3 radical 15. I'm just going to put a note here in case you forgot how we went straight from 135 to the answer. So again, we did the calculator thing, 135 divided by x squared, and looked for our largest pair of whole numbers. Alright, here is a multiplication problem, but it's multiplication of negatives, so just be careful of that. Even though it does have a negative, it looks like, oh, I might be able to minus that. No, not necessarily. But we can put this and this together. Okay, so numbers that are either in front or underneath the radicals, they have to stick together. So 3 times negative 2 will stick together, and then the 10 and 18 can stick together. And these are all multiplications, so multiplication signs. Alright, I got a big number under a radical. Alright, let's see if I get anything. Ooh, yeah, 6 and 5. So notice, see, I saw the 20, but I'm like, that has a factor of 4, and 4 can be taken out. So, because it's a perfect square. So I got to look for a smaller one. So to get a smaller one, I have to keep going. So that was 6 radical 5. So the 180 became 6 radical 5. Making the final negative 36 radical 5. Okay. Not too bad, hopefully, right? So then we got some third root ones and fourth root ones, so you just got to be careful to change this x squared to x third and x to the fourth. But otherwise, I think you'll be alright on those. Alright, why don't you try those two, 9 and 10, on your own. So I will pause the video, and then when you are ready, you can press play to see the answers. Alright, here you go. Number 9 is negative 60, and number 10 is 12 times the fourth root of 2. Alright, looking at the next grouping of problems, I wanted to pause and do one of these together, since they are a little bit different because they have variables underneath the radicals. Let's go ahead and do 13. That one looks kind of nasty, doesn't it? Alright, so both of them have the same index, so we're good. We can go ahead and make this one big old family. And I can already see I got a negative. Let's go ahead and pull that negative out. So I will have 3 times, let's go ahead and see what other, we got 36. 3 times 36 times a to the 7th times b to the 4th. And then times a to the 6th times b to the 2nd. Let's make this look a little bit nicer. 3 times 36 is 108. Now I combine my a's, and when you do this, you add them. So that's 7 a's times 6 a's is really altogether 13 a's. So a to the 13th, and then b to the 6th. Alright, since I've got a little more room over here, let's go out this way. Actually, no, I'm going to split it in half. So this would be a good case where maybe you want to draw your divider line and say, all right, I'm going to deal with my number, and then I'm going to deal with the variables after that. So third root of 108 is 3 radical 4. But I gotta keep my root, or index. Okay, so that's my number, and now I have the third root of, well, I guess I don't want that yet, because I know I'm gonna have to put stuff out front. Let's leave some space. Third root of, alright, so I'm taking out 3s. 3 pairs of 13s would be, or 3 out of 13 would be 4? Yeah, I can take out 4 A's. So 4 sets of 3, which would be 12, leaving me with 1. And then I can take out 2 groups of B's, leaving me with no B's left. Alright. Now let's put it all together. So I took out the A and the B, so I got to move that with the -3. So -3, A to the 4th, B to the 2nd. So I got everything out front taken care of. And now I have the same radical, 3rd radical of, and then I put everything in there, 4 and A. And that is the answer. Yep, we're all good. We got everything. Just wanted to make sure we had everything in there. All right, I think you can try those on your own. So why don't you go ahead and try them? Practice makes perfect. If you are not practicing these on your own, you will be lost on the quiz or test. Just do 11 and 12 and 14. Just do those 3. Press pause. Okay, check out your answers. You're here, 11, 12, and 14. Pause the video if you need to. I'm going to go ahead and scroll down and get started on these last few examples. Alright, these are kind of like distributive and FOIL examples, and these definitely can be tricky. So, let's start with regular, I guess this is a distributive type, so I have a monomial times a binomial, but I cannot combine these in here, radical 5 and radical 2. That's the first thing I would check is, can I combine those? And no, we can't. So this is going to be 10 times that and 10 times that in order to get rid of it. Okay. So when I multiply radical 10 times this, you combine the radical 10 with the radical. So it's like it's a like part of the term. So you'd have your 5 and then 10 times 5 underneath the one common radical. Alright, then we have our minus sign, and then we do it times this one, so I have a 2, and then a radical 10 times 2, and you could do that in one step and multiply those and get 50 minus 20. 5 times 10, and 10 is going to be 2 and 5. So yes, I have a pair of 5s that can come out. So a pair of 5s come out, and that's 5 times 5, which is 25. So this 5 times a single 5. And then what's left under there is only this single 2 right here. Radical 2 minus, alright, 20 is 2 times 2 times 5. So a pair of 2's will come out, giving me 2 times 2. This single times this one is 4. Radical, what's left is 5. And, yep, still cannot combine them, but interesting how they switched. This one became radical 2, and this one became radical 5. So I cannot combine them, so I just leave it like that. And that is the answer. Alright, now let's do one that is a FOIL problem. Let's do it easier, or a harder one, so that way. And this one looks a little bit harder, number 17. Alright, remember FOIL, okay? So this is a FOIL when you have a binomial times a binomial. This one was just distributive. Property. Okay? Alright, when you do FOIL, remember you do first, outside, inside, last. So my first grouping is going to be 6 radical, alright, which is this 6. Now I have 6 times another 6. So remember, this is multiplication, so I'm not just putting a single 6, I'm doing 6 times 6 underneath. Alright, that's my first. Now I'm going to do my outside, which is this one times this one. So that would be, and this is, yeah, since that's a plus, 6 radical 6 times 2. And do my inside, which is these two. And these will, their product will be a negative because this one's minus. Let's get all of our primary colors. Yeah. And then L is last, so the last terms of each one. Alright, I have a negative times a positive, which will give me a negative. And then 6 times radical 2 times 2. And now I can simplify everybody. I'll just do one color. 6 times 6 is 36, but I'm just working it out knowing the square root of 36 is 6. So 6 times 6 is going to be 36. Yeah. Alright, then we're going to add. This will become a 12. Can I take out anything? Yep, that's a 4. I can take a 4 out. So 6 times, alright, so I have a 4 times a 3, and the radical of 4 is 2. So I take out a square root of 4, which is 2, and then all that's left under there is my 3. Minus 6 times 2 is 12, so I'm going to get the same thing, 2 radical 3. So you will notice that there will be some same things will happen. Now, one thing you could do is simplify these beforehand and combine them. Yeah, you could do that. I thought about that before, but then I forgot about it. But anyway, it's going to work out. Those are going to be the same. Alright, and then 6 times radical of 4 is, this is just 2. I'm going to go ahead and move this guy up here, because he doesn't have a square root, so he'll be able to combine with this. Minus 12. So I already took care of that. Now I'm going to do plus, minus, oh, look what's going to happen here. Plus 12 radical 3, minus 12 radical 3. Positive 12 minus 12 is 0. And obviously, if I have the same term minus itself, it's going to be 0. So those will cancel, and 36 minus 12 is 24. Yes, that is the answer. Very, very interesting. Okay? Alright, I want to point out with 18 that this needs to be rewritten. Well, it would help if my pen worked. So when you see that, that is not a way to distribute that exponent. Nuh-uh. Nope, never do that. Write it out twice. This exponent is saying I'm taking this whole term and multiplying it by itself. So literally write it out twice. And then now you have FOIL like in number 17. Alright, 16 is FOIL, 18 is FOIL. Alright, this one's distributive. Let's go ahead and, let's go ahead and do this. Might as well. So multiply these and multiply these. Alright, no numbers out front, so I can just start right away with this. 3 times 12 is 36, and then I have k times k, which is k squared. Okay, this one I do have a number out front. I have this 2. Then I have 3 times 15, which is 45, times k to the third. So single k times k squared gives me the k third. And now I can simplify. Now I have 2 terms, and I treat each one separately. Simplify this first, and then simplify this. Square root of 36 is 6. Square root of k squared is k. Minus, alright, the 45. 45 is 5 times 9. And I know I can take out the square root of 9, which will take out a 3. So minus 2 times 3, radical of, what's left? Alright, the 5 is left. But then I got to deal with this. So this is really a squared, so 2. I can take out 1 set of k. and I would remain 1k inside. Alright, looks like I'm not going to be able to combine these. This one's square root is going to stay. So 6k minus 6k. So this is where somebody might mess up and be like, oh, I can combine these. But no, that radical throws everything off. So this is its own term because it has a radical. It cannot be combined with this one. And that's it. Okay, we are not going to do number 21. Why go back to geometry when we don't have to? Yay! You can do it if you want for fun. But why don't you go ahead and do these three. So go ahead and do 16, 18, and 20. And try them on your own. Press pause, and then play when you are ready to see the answers. Good luck. Here we go! 16 is 34 minus 11 times the radical of 10. 18 is 21 minus 8 times the radical of 5. 20 is x minus the radical of 2x minus 4. And some of those could be rearranged, I guess. And that would be alright. So, that's it for this section. Next is dividing. Woohoo! Oof.